Alright, we'll talk about long division. We're dividing a larger number by a smaller number. What we're going to be doing is dividing by a function, namely x take a. Alright, we need to be able to see the relationship between these two things because they work the same way. 8 divided by 5 goes once, 1 times 5 is 5. So you multiply what you've just got the solution to, and you take it away. Alright, bring the next number down, or do the take away, bring the next number down, divide this by that, 6 times 5, take it away, bring the next number down, divide, answer, times, take, remainder. Alright, so we are checking the division, multiplying, taking away. Bring the next number down. Alright, dividing, down here, multiplying, subtracting. Alright, so dividing, multiplying, subtracting. That's the order that we're going in. And then we bring the next number down. Alright, that's the pattern. There used to be something that I remember to do this about driving a bus, but I didn't have time to look that up. Anyways, what we're going to be doing is polynomials, okay? So we have this number here, which I'm going to describe as your polynomial. Alright, we're going to be dividing this polynomial p of x, which we were calling last lesson. P of x is a polynomial or a function of x. Alright, and this is going to be equal to your quotient function. Okay, so what's left over after we've divided it, times by what we divided by, and then add your remainder. Same thing here. We had what we were dividing. In this case, we're going to be dividing our polynomial. We are equal to our what we divided by. This is this part here. Okay. Times by my quotient. That's what was on top. Plus my remainder. Plus my remainder. They're the same thing. All right. Now, remainder theorem. All right. We can use this to discuss our remainder theorem. Alright. So, what we're going to lead to is we want a remainder of 0 when we're taking out a common factor. If it's divisible by a function, okay, then it's a function, then it's a factor. Alright. So we need to understand a bit more about the remainder and tricks to make sure that we can do this quicker. Now, if your polynomial is divided by a function x take a. Alright, notice that it's x take a. Alright, we'll come back to that when we talk about it in an example. Alright, if it's divided by x take a, then p of this number here, what you're taking away, is equal to your remainder. So, in a moment, we're going to try and do the long division. In fact, I think it's now. Yeah. All right, that's our remainder theorem. Let's do an example with that. All right, we have I'm going to divide by x take 2. Alright. Now, if we were trying to use the remainder theorem, alright, and I have my polynomial p of x here, what number would I try and substitute for x if I was to try and find the remainder? Okay, got to follow. X take a, x take a. So what is a? 2. Okay, so if we were to substitute 2 into this polynomial, we would get the remainder. Alright, I'm going to do the long division style first, alright, and then we'll calculate the remainder the other way. Alright, so I am dividing by x take 2. Alright, we want to set up our long division. Divide by this function, and we're going to have this as our dividend. I think it's dividend. read that off to the back? That's clear. Alright, hopefully that's clear on my recording here. Alright, actually we don't need those brackets. So, this function, my polynomial, divided by x take 2. Now this is where it starts to work similarly, but not quite the same. I'm going to divide each term here, as I go, by x. Alright, not this last term, that. I'm going to divide by x, and I'm going to figure out what's left over. Alright, so 3x cubed divided by x. Alright, 3x squared. So there's my division. What's my next step? We're going to multiply. We're going to multiply 3x squared by this function here. Divided by 3x cubed divided by x, 3x squared. Now I'm going to multiply. Alright, I'm going to take away 3x squared times by x is 3x cubed. Alright. This is what we want. We want these two numbers to cancel. Alright. If you're not getting those two numbers to cancel, then we've done something wrong. Alright. It's going to have to cancel out when we subtract it. Alright. What is negative 2 times by 3x squared? Alright, we've got negative 6x squared. Alright. Now, I chuck this in square brackets because we're trying to take away all of this. Alright? We're not just taking away the first number, we're taking away this function. Alright? So 3x cubed take 3x cubed leaves us with 0, which is great. Alright? That's what we wanted. Then we're going to do minus x squared, or 8x squared, take negative 6x squared. So when I take a negative 6, what am I doing? I'm adding. So negative 8x squared add 6x squared is negative 2x squared. Alright? Bring the next function down. Alright? Or the next term down. And then follow the same process. Alright? We don't need to worry too much about the 0. Negative 2x squared divided by x. And we're back to the same thing. Alright? Yes?
If we were to put those into the graphics calculators, would they solve that?
There is a way to do it on the graphics calculator. We'll come back to that later. Alright? We do need to know this process algebraically first. Alright, so negative 2x squared divided by x is negative 2x. Alright, make sure that's nice and clear. And then multiply. Negative 2x times by this function. I'm going to have to take negative 2x squared. Okay, negative 2x times by x is negative 2x squared. And I'm going to have add 4x. Negative 2 times by negative 2, positive 4x. Alright, I'm going to have to extend this out a little bit. I'm going to give a lot of room for when you're doing this. Clearly I haven't. Alright, negative 2x squared take negative 2x squared. Do they cancel? Alright, what's take a negative? I'm adding, right? So if I'm adding this, that's going to go to 0, which is great. That's what we're looking for. Again, if it doesn't cancel, we've made a mistake. 7x take 4x. Alright, we get 3x, and we can bring the negative 1 down. Again, that 0 doesn't actually need to be there here. 3x divided by x. Alright, plus 3. I'm going to times this again, take away 3x, take 6. Alright. Cancels the first term, which is great. What does take negative 6? Let's add 6, and so I get 5, which is my remainder. Now, assuming the remainder theorem is correct, which it is, small bit, then when I substitute this a value into here, I should get the same number, assuming I've done my long division correctly. So, let's do this. 3 lots of 2 cubed, take 8 lots of 2 squared, add 7 lots of 2, and I'm taking 1. Alright. Yeah. 24, take 32, add 14, take 1. 48, 32, take 1. Yeah. Alright. Equal to 5. So, our remainder theorem is correct. If you take a quick look at this function here, alright, when I've divided my polynomial by x take a, this is what I'm left with. Alright. If I substitute a in for where x is, what happens to this set of brackets here? X take a take a would be 0. What's q of x times by 0? 0. And what are you left with? Just the remainder. Okay, so when you do your substitution, it's only when you're dividing by a function x take a. Alright, let's move on to the next thing. We're going to talk about factor theorems. People okay with that? Anybody want to ask a question?
One more example.
We're going to go through something very similar in a moment. Alright, where I do this whole process again. Alright. So, will that be okay? Alright, I'm going to get rid of this side here. And we're going to talk about the factor theorem. Now, because we're trying to take out common factors from a polynomial, we want the remainder to be 0. So, if we have a polynomial p of x, in fact, polynomial p of x, right, if p of a, some number that we've substituted into our polynomial, is equal to 0, this means my remainder is 0 according to the remainder theorem that we just spoke about. Alright. Which means that p of x, let me say that again. X take a is a factor of p of x. Alright. Which means we can remove that as a common factor, that function, and then there will be nothing left over at the end of it. Alright. I did actually forget something here. We'll come back to it. Alright, so factor theorem, if we substitute, we get a 0. It's a very important number, which means we can take it out cleanly as a common factor. Alright. Can I erase this right hand side? Yes. X. Now the reason we're trying to factorize polynomials is so that we can solve them like we have done with our quadratics, where we use the null factor theorem. If it's equal to 0 and we have numbers times by each other, then we can find out what the solutions of x is. Same stuff with our quadratics. Alright, let me double check. Alright. Alright. So, going by our factor theorem, I'll chuck a line through here. If x take 1 is a factor of this whole polynomial, what can we do to quickly show it? Give it a shot. We can divide it, alright, and do that really long process which we just had over here, alright, which we'll do in a moment. But a quicker way to show that it's a factor is to substitute P of A. What is A equal to here? Alright. A is equal to 1, so if I do P of 1, what are we expecting to see? We should expect 0. If it's a factor, then it should be 0. Alright, 2 times 1 cubed, take 1 squared, take 7 multiplied 1, add 6. Alright. Started big and I went small. 2 take 1, take 7, add 6, and we get 0. Alright. So is x take 1 a factor? Yes, it is. Remainder of 0. If our remainder is 0, then it is a factor. So let's use our long division to find out what's left of this polynomial once I take out x take 1 as a common factor. Alright. What we're using this for is to try and solve polynomials, okay? Like we have done with our quadratics, okay? When we can factorize our polynomials, which there's only a few that we can actually do realistically, alright, then we can solve those using our null factor theorem. Anyways, so I'm doing this polynomial, I'm dividing by a function. I'm going to set up my long division. X take 1 is going to go over here. X take 1, alright, and then my function in the middle. I hope that's enough room. We'll see what goes on. Alright. Now, be careful if you are missing a term, such as if x squared disappeared here. Alright. When you're writing it in here, you still want to write that 0. Okay? It's going to be very important when we're writing that in, because when we're carrying and bringing the next term down, that's where you're going to likely make a mistake. Alright? So you want to write the whole polynomial out, even if there's a 0 coefficient. Alright? I'll show you another time. Anyways, where am I starting here? Starting on the left, I want to divide by x. Exactly. 2x cubed divided by x is 2x squared. Alright. Take square set of brackets, so I know that I'm taking the whole thing away, times this, x take 1 by 2x squared. Alright. So I get take away 2x cubed, and then take 2x squared. Alright. Negative 1 times by 2x squared is negative 2x squared. Keep carrying on. So 2x squared take 2x, 2x cubed take 2x cubed. 0, which is what we wanted. Alright. And now I'm doing negative x squared take negative 2x squared. So I'm adding 2x squared, not taking it away, and I get x squared. Alright. Bring the next term down. Alright. And then continue to divide. X squared divided by x, positive x, take away, multiply, x squared, take x, alright, x squared, take x squared, again cancelling, so we're doing well so far, alright, negative 7x, take negative x, negative 6x, again, bring the remainder down, next term down.
Negative 8x.
Take away a negative, which means we're adding on x. Alright? So negative 7 add x, or add 1 is negative 6. Alright, keep going. Negative 6x divided by x is negative 6. Again, take away, multiply. Alright. Take 6x, negative 6x, add 6x, negative, negative, 0, plus 6, take plus 6, 0. Alright, remainder is 0. That's good, because that's what we showed was in the first place. This means that my polynomial is now my quotient. Alright, yeah, bracket's good. Times by my factor. Alright, and I'm adding nothing because I've got a remainder of 0. That goes back to the first thing that I wrote up here. Okay? P of x is equal to my quotient, that's this part here, times by the factor that I just took out. Now, we can completely factorize this by being able to factorize 2x squared, add x, take 6. Now we've done the quadratic stuff before, so I'm assuming we know how to do this stuff. Alright. So we could say, and I'll skip ahead a little bit because I've got my answer over here. We've got x plus 2, 2x take 3, and x take 1. So if we factorize the 2x squared, add x, take 6, we get these two terms, and then we've completely factorized the polynomial, which is great, because when it's equal to 0, then we know that x is negative 2, we know that x is 1, or we know that x is 1.5, or 3 on 2. That's what we need to know at the moment. So, quick recap. We went through our rule up here. Alright. Our polynomial is equal to our quotient times by my factor. Add my remainder. Alright. We want that remainder to be 0 so we can actually bring it out properly. Alright. We spoke about the remainder theorem, that I can check if there's a remainder of 0 ahead of time, like I did here. I substituted a value in. If it's 0, then I know it's a factor. Okay? If you don't know what your factor is, or the question doesn't tell you, hey, try this, you want to start with either positive or negative 1, and then go up from there. Alright? Everything at the end should be factors of your constant here. Alright? So, 2, negative 3, and negative 1, what do they multiply to become? Positive 6. Alright? So, that's a clue as to which factors you can try first in order to get a remainder of 0 and factorize your polynomial. Alright? Otherwise, we spoke about our factor theorem, which is where that part 1 comes from. Alright? If we can check the remainder is 0 ahead of time, it will help us. Other than that, I believe that's all for today.